Hi all, welcome back to another session of Boilchem Tutor. In this session, I am discussing some of the important multiple choice questions that have already asked in various competitive level exam related to the topics that I have already covered. In this session, I am discussing the question related to amines, cyanide and isocyanides. So my first question is, acetamide is treated separately with the following reagents. Which one of these give methylamine? Option A is PCl5, B option is NaOH plus Br2 and C option is soda lime and D option is hot concentrated sulfuric acid. In this case, acetamide means it is a 2-carbon atom containing amide and it is converted into methylamine. That means one carbon atom is losing and amide is converted into amine, that is NH2. So there is a degradation of one carbon atom. So that is possible only by sodium hydroxide and bromine. That reaction is usually named as Hofmann-bromamide degradation reaction. So option B is correct. To the second question, that is, oxidation of aniline with manganese dioxide and sulfuric acid produces A option is phenyl hydroxylamine, B option is nitrobenzene, C option is parabenzoquinone and D option is phenol. So usually when aniline undergo oxidations, there can be two chances. One, it is parabenzoquinone and nitrosobenzene. But the formations of parabenzoquinone is easily occurred when the reagent oxidizing agent is potassium dichromate bar sulfuric acid or manganese dioxide in the presence of sulfuric acid. But the nitrosobenzene are obtained when aniline undergo oxidation with peroxide, that is hydrogen peroxide, or Carros acid, like it is Carros acid, that is H2SO5. So here oxidation of aniline is with manganese dioxide and sulfuric acid. So the option C is correct, that is parabenzoquinone. So coming to the third question, that is, primary and secondary amines are distinguished by A option is bromine bar potassium hydroxide, B option is HOCl, C option is nitrous acid, that is HNO2, and D option is ammonia. We have already discussed that primary and secondary amine can be distinguished by Hinsberg reagent, that is benzene sulfonyl chloride, or it can be distinguished by nitrous acid. So here option is nitrous acid, that is C option is correct. And again, when primary amine undergo treatment with nitrous acid, the main product is alcohol. But when secondary amine is treated with nitrous acid, there is an elimination of water molecule and it results in the formations of a nitrosoamine. So option C is correct, that is HNO2. So coming to the fourth question, that is, aniline on reaction with acetyl chloride gives A option is phenol, B option is acetamide, C option is acetanidide and D option is benzene. So when aniline is treated with acetyl chloride, there is an elimination of an HCl from the amino group present in the aniline and it results in the formation of an acetanilide. So the option C is correct, and again it is a common reaction useful for protecting the amino group present in the aniline during the electrophilic substitution reaction. Coming to the fifth question, that is, the compound which on reaction with aqueous nitrous acid at low temperature products an oily nitrosoamines is A option is diethylamine, B option is ethylamine, C option is aniline and D option is methylamine. So we have already discussed that it is a distinguishing test to distinguish primary, secondary and tertiary amine. Again, when primary amine on treatment with aqueous nitrous acid, the main product is alcohol. And secondary amine on treatment with nitrous acid, there is a formation of a nitrosoamine. And the tertiary amine, when treated with nitrous acid, there is a formation of a soluble nitrates. But if it is aromatic tertiary amine, means there is a chance of an undergoing electrophilic substitution reaction with nitrous acid. So here the main product is nitrosoamine. So it is given by a secondary amine. So around this option, the secondary amine is diethylamine. So option A is correct, that is diethylamine. So coming to the sixth question, that is aniline react with phosgene and potassium hydroxide to form. First option is phenol, second option is benzoyl chloride, C option is phenyl carbamic chloride, that is benzene ring with NHCOCl, and D option is phenyl isocyanate, that is NCO. So in this option, when aniline is treated with chloroform and potassium hydroxide, means the main product will be isocyanide, that is phenyl isocyanate. So that reaction is having the name, that is carbylamine reaction. But here instead of chloroform, the reagent is phosgene, that is carbonyl chloride, that is COCl2. So when aniline on treatment with carbonyl chloride, first chance is the formations of a phenyl carbamic chloride, but it is highly unstable and it get converted into phenyl isocyanate. So the option D is correct, that is phenyl isocyanate. So coming to the seventh question, that is primary amine on heating with carbon disulfide, that is CS2, followed by excess of mercury chloride yield isothiocyanates. This reaction is called, A option is Hofmann mustard oil reaction, B option is Perkin reaction, C option is Price reaction, D is Diels-Alder reaction. So here option A is correct, that is Hofmann mustard oil reaction. So what is Hofmann mustard oil reaction is that when primary amine is treated with carbon disulfide, that is CS2, in excess of mercury chloride, there is a chance of formations of a phenyl ring with an NCS group, that is isothiocyanate group, and that reaction is termed as an Hofmann mustard oil reaction. So option A is correct, that is Hofmann mustard oil reaction. So coming to the eighth question, that is which of the following compound does not react with the NaNO2 and HCl? Option A is C6H5OH, that is phenol. B option is C6H5NH2, that is aniline. C option is CS3 whole thrice CNO2, that is 2-nitro-2-methyl propane. And D option is CS3 whole twice CHNO2, that is 2-nitropropane. So NaNO2 and HCl on reacting will get nitrous acid. So phenol can react with nitrous acid and it result in the formations of a para-nitrous of phenol. Because OH is a strongly activating group, so on reaction with nitrous acid, it undergo electrophilic substitution reaction at the para position of the benzene ring. So it result in the formations of a para-nitrous of phenol on reaction with nitrous acid. When second option C6H5NH2, that is aniline. Aniline can also react with nitrous acid and that reaction is having the name, that is diazotization. That is, it is a convenient method for the formations of a diazonium chloride. Third option, that is CS3 whole thrice CNO2. It is a tertiary nitro compound and it cannot react with nitrous acid because there is no more hydrogen present at the tertiary carbon, and so it cannot react with the nitrous acid. So the option C is correct. And when we come to the D option, that is CS3 whole twice CHNO2, it is a secondary nitro compound. So it can also react with the nitrous acid because there is a one hydrogen atom at the secondary carbon. So on reaction with nitrous acid, it results in the formations of a pseudo-nitrile with the eliminations of a water molecule. So option C is here is correct because C cannot react. That is CS3 whole thrice CNO2 cannot react with the nitrous acid. Coming to the ninth question, that is aniline on heating with concentrated nitric acid plus concentrated sulfuric acid mixture yields A option ortho and paranitro-aniline, B option metanitro-aniline, C option a black tarry matter, D option no reactions. Here, when aniline is directly treated with the nitrating mixture, that is concentrated nitric acid and concentrated sulfuric acid, there is a chance to undergo oxidation to the aniline, and that means a black tarry matter will be obtained. Again, in acidic medium, the protonations can take place to the amino group present in the aniline and it results in the formations of an anilinium cation. Actually, this anilinium cation deactivates the benzene ring towards the electrophilic substitution reactions. Again, if nitrations is carried out controlled manner, aniline has a chance to undergo nitrations and result in the formations of a meta-nitroaniline. Because in acidic medium, there is a chance of forming anilinium cation and which deactivate the benzene ring, and so the nitro group can attack at the meta position of the anilinium cation. So here they are asking the question, that is aniline on heating with concentrated nitric acid and concentrated sulfuric acid mixture. So here first chance is a black tarry matter. But if the question asked is controlled heating with concentrated nitric acid and concentrated sulfuric acid, means the option B can be correct, that is meta-nitroaniline. So here option C is correct, that is a black tarry matter. So coming to the next question, that is a compound A has a molecular formula C7H7NO. On treatment with bromine and potassium hydroxide, A compound gives an amine B, which gives carbylamine test. B upon diazotization and coupling with phenol gives an azodine. So A can be. A option is C6H5CONHCOCH3. B option is C6H5CONH2. C option is C6H5NO2. And D option is ortho meta para C6H4NH2CHO. So in this case, first the compound is having the molecular formula C7H7NO. So which on treatment with bromine and potassium hydroxide, means it is a Hofmann degradation reagent. So for undergoing a Hofmann bromamide degradations, the starting material will be an amide. And this A is converted into amine. That means a primary amine is formed. So primary amine can undergo carbylamine reactions. So A can be an amide. Again, B can undergo diazotization reactions and coupling with phenol gives an azodine, means B should be amine, that is a primary amine. So A should be an amide and A should be C6H5CONH2. So B option is correct. Coming to the next question, in the reaction CH3Cn plus 2 hydrogen gives a compound X, and which on boiling water treatment it gives Y. The term Y is A option is acetone, B option is ethanamine, C option is acetaldehyde, D option is dimethylamine. So here the starting compound is CH3C triple bond N, that is a cyanide. So when it add with 2 hydrogen, means this 2 hydrogen is added to the triple bonded Cn. So the compound will be formed, X will be aldimine. So an aldimine react with boiling water or when it is heated with water, means the compound will be converted into aldehyde. So it will be converted into CH3CHO, that is acetaldehyde. So option C is correct, that is acetaldehyde. So coming to the next question, identify the product C in the series. The series is CH3Cn in presence of sodium bar ethanol gives a compound A. Then on treatment with nitrous acid gives another compound B, which on treatment with copper bar 573 Kelvin it gives C. So options are given: CH3COOH A option, B option is CH3CH2NHOH, C option is CH3CONH2, and D option is CH3CHO. So first it is the compound is CH3Cn, that is acetonitrate, or it is a cyanide, and cyanide when undergo reduction, that is sodium in the presence of ethanol, means it is actually a reduction. It is termed as a Mentier's reductions and it results in the formations of a primary amine, that is CH3CH2NH2. Then after that it is treated with nitrous acid. Then when primary amine undergo reaction with nitrous acid, it results in the formations of an alcohol, that is CH3CH2OH. Then on treatment with copper bar 573 Kelvin, means it mainly undergo dehydrogenation, that is 2 hydrogen will be eliminated and it result in the formations of an aldehyde. So the compound will be CH3CHO. So option will be D. To the next question, that is Gabriel-Thalamide reactions is used for the preparations of A option is primary aromatic amine, B option is secondary amine, C option is primary aliphatic amine, D option is tertiary amine. So what is Gabriel-Thalamide reaction is that first thalamide is treated with alcoholic potassium hydroxide. So on reaction with alcoholic potassium hydroxide, we are getting potassium salt of thalamide, which again treated with any alkyl halide, then gives alkyl group containing alkyl group will be attached to the thalamide. Then undergoing hydrolysis, we are getting primary aliphatic amines. So it is mainly useful for the preparations of a primary aliphatic amine. So option C is correct. To the next question, that is aniline is treated with a mixture of sodium nitrite and hypophosphorus acid, that is S3PO2. The product formed is A option is aniline disonium hypophosphite, B option is benzene, C option is anilinium hypophosphite, and D option is none. So here sodium nitrate and hypophosphorus acid means where there is a formations of a nitrous acid. So aniline on treatment with nitrous acid means we are getting a disonium salt. So here benzene disonium hypophosphate can be obtained. But this hypophosphorus acid, that is S3PO2, can act as an acid as well as a reducing agent. So after the formations of a benzene disonium hypophosphite, there is a chance to undergo, that is reductions, and it result in the formations of a benzene. So option B is correct, that is benzene. To the last question, the product A and B in the following sequence of the reactions respectively are R1CH2NO2, first is the treatment with base and second is with R2Br, gives a compound A. Then on treatment with titanium trichloride, that is TiCl3, gives a compound B. So what is A and B? So options are given, that is A option is R1 R2CHNO2, R1 R2CO. B option is R1 R2CO and R1 R2CHNO2. C option is R1 R2CHNO2 and R1 CH double bond NOR2. D option is R1 CH2 NOR2 and R1 R2C double bond NOH. Compound, that is reactant, that is R1CH2NO2. Here NO2 is acting as a strong electron withdrawing group. So the CH2 group adjacent to this NO2 act as an acidic in nature. So when it is treated with base means it can abstract a hydrogen atom. So it results in the formations of an anion. Then after the formations of an anion, when it treated with an alkyl halide, that is second reaction, that is R2Br, that R2 get attached to the CH group. So the compound formed, that is A compound, will be R1CH2NO2. So next reaction is titanium chloride reaction. So titanium chloride is a better oxidizing agent, so it get oxidized. So it get oxidized to ketone. So it result in the formations of compound B will be R1 R2 C double bond O. So the A option, A compound will be R1 R2 CHNO2 and B compound will be R1 R2 CO. So option A is correct, that is R1 R2 CHNO2 and R1 R2 CO. So that is all in this session. Hope you like this session. Stay tuned for the next session. Till then, bye.